Hello everyone, in this video I want to talk about precipitation reactions, and along with precipitation reactions we need to talk about the solubility rules and the idea of solubility. So with that, a precipitation reaction is typically we call these in regular chemistry, or at least a gen chem type thing, we call them double replacement reactions. These are reactions that produce something called a precipitate, and that precipitate is a product. A precipitate is a solid compound, here it is, solid compound that's insoluble in the product. So an insoluble solid product formed by a reaction that is in solution. Okay, so these are all aqueous. This is what solution means, aqueous, aqueous. These two things combine, you end up with AY. There's your precipitate. Here's your XB that stays aqueous. Okay, so this is what we're concerned about. Okay. So that's precipitation. Precipitation, again, forming that solid product. It's insoluble. So when we go on one step further, let's look at the idea of solubility. Solubility rules guide precipitation reaction. The idea of solubility, as it says up here, is the amount of substance that can be dissolved in a given quantity of a solvent at a given temperature. So this is actually important. So it's the amount of something that can be dissolved, okay, in an amount of solvent, typically water, and we have to factor in temperature, okay? So typically if you take sugar, sugar is the amount of thing that can be dissolved, so the substance that can be dissolved, we'll say that's sugar, and we're going to dissolve that in a solvent, in a given quantity of solvent, okay? Let's say that's water, okay? Don't forget a given quantity. Let's say that's 1 liter of water, okay? And I have to specify so far at 25 degrees Celsius, okay? So those are 3 things we need to talk about. So not only is it how much sugar in how much water, but at what temperature, okay? So those are things, and there's different solubility graphs we can look at. That's not the focus of today. But typically, as temperature rises, for most things, as temperature goes up, solubility increases. Now, that's for salts, for most salts, okay? It's actually the opposite for gases, okay? As temperature rises, solubility decreases for gases. Oops, gases. Okay, sorry, I'm both so sloppy. All right, so when we talk about, let's go back to salts. Solubility applies to salts being dissolved in water. In order to determine this, we must know some rules. Okay, these are not to be memorized, but here is an example of a solubility chart. Okay, they come in different forms. Sometimes you just have a bunch of rules. This one says these are all soluble. Here are the soluble ones, and here are exceptions to these. Okay. Now it flips it on you. It says these are the insoluble compounds. Here's the insoluble. Notice they are, oh, there's one right there. I screwed that up. Notice these are insoluble. They are anions, and here are important exceptions to these. Okay, so again, not to be memorized, but definitely to be interpreted. Okay, we're going to come back to this in a second. Let me just clean up the ink off of this so I can refer back to this later. Now, as far as my classes go, and for most classes, you just need to know these 3. Okay, these are very general. Now, as far as these goes, it says all nitrates are soluble. Okay, so it doesn't matter if it's potassium nitrate, magnesium sulfate, barium sulfate, cobalt sulfate, doesn't matter. Oh, gee, I kept saying sulfate. Magnesium nitrate, sodium nitrate, cobalt nitrate, ammonium nitrate, those are all soluble. Any group 1 compound is going to be soluble. Okay, the sodium compounds, the sodium compounds, the lithium compounds, the potassium compounds, those are all soluble, and then ammonium salts. So anytime you see NH4, you see solubility there. So this is highly soluble, okay? Know these 3, especially for AP, okay? Now, just because you memorize these 3, it doesn't mean that everything else is insoluble. Don't think that, okay? So let's go back to let's go to some examples here. Let's get this out of the way, okay? So sodium carbonate, is that soluble? This is going to be soluble, Okay, why? Because this is a group 1 metal compound. Okay, now lead 2 sulfate, I'm going to guess as being insoluble. Okay, let's take a look at our rules. Lead 2 sulfate. Sulfate. Okay, so here it says sulfate. Sulfate compounds, this is in the soluble area. But here it says this is an exception to being soluble. So lead 2 sulfate is insoluble. That's how you would interpret that chart. So I was correct. Cobalt 2 hydroxide. Cobalt 2 hydroxide. I'm going to tell you this, most hydroxides are insoluble. Whoopsie, went the wrong way. Most hydroxides are insoluble. There it is in the insoluble area. So since it says that these hydroxides are insoluble, it's not listed as an exception to that insolubility. That makes this one insoluble. Barium nitrate, that's an easy one. Anytime you see nitrate, that's soluble. It will dissolve in water. And this is an ammonium compound that's soluble, that will dissolve in water. Okay? So I noticed here as I was thinking through some of my notes here, I just realized that soluble versus insoluble, and I just wanted to say this, and I definitely should have started with this. This means able to be dissolved. And this one's not able. Not able to be dissolved. Okay? Soluble and insoluble. Next. Okay, now here's writing some precipitation reactions. Okay? So again, these are double replacement. I mentioned this at the beginning of the slides, or the beginning of the video. Double replacement reactions. So in order to do these, you have to consider each one and write the formulas correctly for each substance. So here I have magnesium nitrate. When you look up magnesium nitrate and you get all the charges correct, it looks like that. Okay? That's not the realm of this video. I'm not going to go over how to write formulas. So make sure you guys brush up on that if you need to. Sodium hydroxide's like this. And that's an arrow. That's a yield symbol. And then what we're going to do is switch the cations, or switch the beginning things. Okay? So now I have sodium nitrate. So the sodium is now with the nitrate. And the magnesium is with the hydroxide. Okay? And you could go through and balance. We're not going to do that right now. But what I want to need to determine is this a precipitation reaction? In other words, will this produce something that is insoluble? Okay? If both products, the sodium nitrate and magnesium hydroxide, let me say it again, if both products are soluble, in other words, they both dissolve in water, then this is not a viable precipitation reaction. There's no precipitate that forms. One of these has to be an insoluble solid. Okay, one of these two products that I just underlined in red. So this is aqueous. This is not our precipitate. Why? Because sodium, this fulfills each of two rules. Sodium's a group 1 metal compound. Those are always soluble. And nitrates are always soluble as well. So that's not our precipitate. So far, no precipitation reaction. So now we got this idea behind this hydroxide. So let's go back to our rules. Okay? So here's hydroxide down here. Okay? We know that most hydroxides are insoluble. Okay? So compounds of alkali metal cations, alkali, that's group 1. Well, this is group 2. Magnesium hydroxide is group 2. Okay? Oops. So this is, so far, it's still insoluble. This is an exception, this is an exception, this is an exception. So is that one. It's not magnesium. Magnesium hydroxide happens to be insoluble. Okay? So this one is our solid. This is a precipitation reaction. Okay? That's a precipitation reaction. Next, let's try this one. Here we have barium chloride. Barium chloride written correctly is BaCl2. And potassium sulfate is K2SO4. Okay? The cation switch places. And you can write these in any order. And BaSO4. Okay? Now, again, is this a precipitation reaction? Let me reiterate. Let me say it this way. If it is a precipitation reaction, one of the products, that could be KCl or BaSO4, one of those has to be a solid, has to form a solid, an insoluble solid, okay? Can't be KCl. This is not a precipitate. We'll mark that as an aqueous. That'll stay dissolved in water, okay? Those particles will not combine together and form bonds. Barium sulfate. That's a little bit more difficult. Let's take a look at that one, okay? So barium sulfate, here is sulfate here, and these are soluble. So everything up here is soluble. Here's the exceptions. Barium is an exception of this highly soluble sulfate. So therefore that makes it insoluble. This is our solid. This is a precipitation reaction because that formed an insoluble product. Insoluble means it's not able to be dissolved. Okay, let's do a couple more. Iron 3 sulfate and lithium hydroxide. I'm going to jump ahead to this one down here, lead 2 nitrate and potassium iodide. This one's interesting. Lead 2 nitrate looks like that, and potassium iodide looks like this. Okay, so is this one a precipitation reaction? Well, let's switch the places. We have KNO3, and again, you can write the products in any order you want. Okay, you can look at the order. You can look at any solubility chart, not just the one I showed you now 3 or 4 times. You can look up any solubility chart. So if you don't like the one I have, look it up online. This is highly soluble. That is not the source of your precipitate. This forms a yellow compound, a yellow solid precipitate. This is indeed a precipitation reaction. For your last example, let's look at sodium sulfate and potassium hydroxide. Okay, there's our reaction. Now watch this, guys. Group 1 metal, highly aqueous, highly aqueous. You will never see this form a reaction. You will dump sodium sulfate and potassium hydroxide into water. You'll dissolve them. You'll dump them together. You combine them. You're expecting something magical to happen, and nothing magical happens. It just forms ions. Those ions will not combine. We would actually relabel this as no reaction or no apparent reaction. Okay? That's all I want to do for precipitation reactions. We'll move on to this. We'll extend this on the next video. Anyway, if you have questions, let me know.